Alright, so to finish up section 4.5, we're going to start talking about altitudes. You're also going to do a Geometry Sketchpad activity in this as well, so this will be another short video. Okay, so the definition of an altitude is that it's a perpendicular segment from the vertex to the opposite side. Okay, so if I were to draw my perpendicular segment, it's going to go from my vertex to my opposite side. Okay, and this is going to make a 90-degree angle. Okay, if I were to draw it here, notice how it goes outside of my triangle. Okay, if I were to draw a perpendicular segment or an altitude from this vertex to this opposite side, I can't get a 90-degree angle anywhere else inside that triangle. So I got to go outside of that triangle, and I'm going to extend this side so I can get my 90-degree angle here. You're going to look at this a little bit in your Geometry Sketchpad. So same thing goes for the next one. Okay, so this vertex to the opposite side. Well, I can't get a 90-degree angle anywhere in here, so I'm going to go outside of the triangle until I get that 90-degree angle. So I'm going to extend this side of the triangle. Okay, and I'm going to manipulate this altitude until I get this 90-degree angle. Okay, so before you start doing your Geometry Sketchpad, let's look at these two examples first. In this acute triangle, okay, this perpendicular, or this altitude, is inside of my triangle, right? Now in this example, just like we did up top, my perpendicular my altitude has to come outside of my triangle in order to make this to be perpendicular, to make this right angle with this side PR of my triangle. So all I have to do is I make this altitude, and I just have to extend the side of my triangle out to get this altitude, to make it a 90-degree angle. Okay, so in this picture we have our three altitudes. Okay, so again, these altitudes had to extend outside of the triangle in order to get this perpendicular line. Okay, these had to be 90-degree angles. The concurrency of the altitudes of a triangle, this theorem. So the lines containing the altitudes of a triangle are concurrent. So these three are my altitudes. Okay, they meet here at this point G. The lines containing AF, BE, and CD meet at G. Okay, this point of concurrency of my altitudes is going to be called the orthocenter of the triangle. Okay, so now you're going to take a little bit of a look at that with acute triangles, obtuse triangles, right and isosceles triangles in this sketchpad. So if you go to your next slide, okay, you're going to go to My Outbox again, click on CP Geometry, and open up the altitudes file. Okay, you're going to manipulate those angle measures so you can get your different triangles, an acute, obtuse, right, and isosceles triangle, and tell me what you notice about that point of concurrency, which is called the orthocenter. Once you do that, you're going to turn to the next slide, and it's going to give you a summary of what you did in your sketchpad activity. Okay? Then I want you to go through and I want you to answer these next questions on your own.